So today we will get introduced to the hash tables. So before going ahead, do you know what is hash? If you are not familiar, then I have created a 3-minute video on this. So you will find the link in the description. Now let's go ahead with the hash tables. So imagine we need to keep a list of all the members of some club while being able to search for any specific member. We could handle it by keeping the list in an array or a linked list. And to perform a search, iterate the elements until we find the desired one. We might be searching based on their name, for instance. In the worst case, that would mean checking all members. The one we are searching for it could be a last, it could not be present, or it might be in the half of the list. So, in the complexity theory term, the search would then have the complexity of order of n, and it would be reasonably fast if the list is small, but it would get slower and slower in the direct proportion to the number of elements in the list. So, how could we improve this? Let's suppose all the members of this all the members of this club had a member ID. So let's say there is an ID which happen to be in a sequential number reflecting the order in which the member joined the club. So this is 1, 2, 3, 4 like this to the n in a sequential order. So can we improve this situation now? So we need to assume one more thing, like let's say the search by ID is acceptable for now. Okay, then what we could do, so instead of a linked list instead of a linked list, we can put all these members in the array the in which they join to the club. So what will happen, the index of the member would match with the id of the member, right? The member id of the member in the join in the club. So at any point, if we want some member to be searched, like let's say I want a 10th member, I want a member ID, member whose member ID is 10. Then what I will do is to get the element present at index 10 in the array. So that would give us the best possible complexity, that is order of n. So this approach will give us order of 1. This is the best possible complexity in computer science. But the but we have made one major assumption here, that the ID will always be in a sequential order. But will that be a case in real life scenarios? How many IDs we have seen in our offices are in a sequential order? So that is not a true assumption or the right assumption to made here. So let's revert that assumption now. IDs are not in a sequential order. They could be a big string, or they could be a big number, and random numbers. Not necessary will be in a sequential order. So can we solve this problem still? Let's think.
So here comes the hash function to rescue us. So we have the limitation that the member ID will not necessarily be in a sequential order, or it will may not be an integer, or it can be an alphabet or string. So how to overcome that? So we can use the hash function here. So what hash function will do, we will provide the member object to this hash function, and this will generate an hash code, which is nothing but an number. This can be a big number, 32-bit or 64-bit number. Okay, so that is the function we have. Now how we can use this? Okay, to understand that, let's assume that we have a 16 buckets. It can be any number of bucket, but just for the sake of this, just for the understanding, let's take there are 16 buckets. So this is bucket 1, this is bucket 2, 3, and like this is the 16th bucket. Okay, now can we map the member object to one of this bucket? Is there any way to map? Yes, there is a way, because we can find out the hash code of the input object, and then we can do the modulo 16, right? So if we do the modulo 16 to this number, it will give us a number in the range between 1 to 16. It means the input member object is mapped to this one of the bucket, right? So let's say there is a member 1, m1. Okay, let's say this got mapped to the bucket 2. Okay, so we kept the this member object in bucket 2. Okay, then let's say there is a second member came, and it's we find out the hash code and then do the modulo operation by 16. It gives the another output, that is bucket 1. Okay, now let's say there is a another member 3, whose hash we find it out, and we do the modulo operator, and it also provided the second bucket second bucket. Now there is a problem, right? Two members are pointing to the same bucket, right? So we need to find a way how we should put these two members in the one bucket, and this is called the collision. If two input objects has the same bucket, then this is called the collision problem. Now how we can solve this is, in the bucket we can have the linked list. So member 1 will member 2 basically, sorry, the member 1 is assigned to bucket 2. So member 1 will reside here as a first node in the linked list, and the member 3 will reside here in the next node, right? So like this linked list will keep on growing. So how to read from these buckets? Let's say I want to read a member 3 now. So what I will do is I will pass this member 3 object to this hash function. This will give me the hash code, and then I will do the modulo operation on the hash code. It will again point me to this bucket 2, because hash code is going to be a unique one. If I execute the hash function on the same member infinite number of times, it will always give me the same hash code. Okay, so we will get pointed to this bucket 2. Now there is a linked list, so I will iterate over this linked list one by one, and I will check whether m1 is equal to m2, sorry, m3. Whether m1 is equal to m3, it is not, so I will move on to the next node in this linked list. M3 is equal to m3, yes, so I will just return the value present at this node in the linked list. So that is how the read operation will work. So with this, I hope you understood what is hash table and how it works internally, how it stores the data with the help of buckets and linked list. Now, this hash table is a very common data structure in all the programming languages, and it is readily provided as a feature of any high level programming language. Now we have discussed the hashing. We are ready to look into the distributed hashing. Thank you for watching this video.